Hello, everyone, and thank you for joining today's webinar. My name is Reese, and I'm going to be your moderator today. We're going to kick off the session in a couple of minutes at the top of the hour. We're just waiting so everyone has a chance to join. In the meanwhile, though, we'd love to hear from you. So let us know where you're joining from using the chat or the comments, depending on what platform you're watching on. And yeah, tell us something that you'd like to get out of today's webinar. If you've got any burning questions for our panelists today, let us know in the comments and we will save them ahead of time. Just a quick note as well, the session is being recorded. So if you need to leave because of a meeting or anything like that, this will be available for replay on LinkedIn, YouTube, Facebook, and it will be on DataCamp as well. And we will send the recording out to anyone that's registered for the event. I'll be back in a second to repeat these messages for any new joiners, but until then, enjoy the background music. Hello, everyone, and thank you for joining today's webinar. My name is Reese, and I'm going to be your moderator for today's session. We're going to kick off in a couple of minutes. We're just waiting so everyone has a chance to join. In the meanwhile, though, let us know where you're joining from. Obviously, we're highlighting a few people on screen now. So yeah, let us know in the comments, and we'll get you up on screen. Tell us something that you'd like to learn about in today's webinar. If you've got any questions as well, send them through as soon as they spring to mind, and I will save them for our panelists. Quick note to say that the session is being recorded and will be available for replay on whatever platform you're watching on now, apart from Twitter. But yeah, it'll also be sent. The recording will also be sent out to anyone that has registered for the event as well. So if you haven't already done that, go register on DataCamp, and we will send you the recording as well as a few other goodies. Brilliant. I'll be back to repeat these messages once more for any new joiners in a minute or so. But until then, enjoy the background music. Hello, everyone, and thank you for joining today's webinar. My name is Reese, and I'm going to be a moderator for today's session. We're going to kick off in, about 25 seconds or so. We've just been waiting so everyone has a chance to join. In the meantime, let us know where you're joining from. Lots of people on screen, lots of locations as well. So nice to see such a wide variety of people joining. Let us know something that you'd like to get out of today's webinar. And if you've got any burning questions ahead of the session, please let us know in the comments and I will save them for our panelists. Quick note also to say that the session is being recorded. So if you need to jump off at any point, it will be available for replay on social platforms as well as on DataCamp. If you haven't already registered for the event on DataCamp, please go do that and we will email you the recording as well. Brilliant. Well, as mentioned, we're going to have a Q&A towards the end of the session. So if you have any questions, please ask them as soon as they spring to mind and I will save them. You don't need to wait until the actual formal Q&A. Brilliant. I think that's everything from me. So now I'll hand you over to your host for today's session, Adele. Adele, please take it away.
All right. Hello, everyone. Thank you all so much for joining us today. I am so excited and privileged to be hosting this session today. As you've seen, we've been showing the love we've been getting on screen. Everyone from all over, a lot of people from all over the world have been joining us for this live session today. Folks from the US, folks from Turkey, Zimbabwe, Thailand, Bharat, Algeria, Ethiopia, people from all over the different states in the U.S., Puerto Rico, New York, Really awesome to see people from all across the world. It brings us so much happiness to run these events, makes them all worth it. Um, hello, everyone. For those who are joining us right now, my name is Adele. I'm sure you've noticed that large language models and other generative AI tools have become widely popular in the last year. As an individual, it's pretty easy to get started with ChatGPT, but if you're in an organization, you have quite a few different choices that you need to make. Should you buy a license for an API? Should you train your own model? Should you fine tune an open source model? And do you use an off the shelf large language model, for example? Here to answer this particular question of buy or train, how to leverage large language models in the enterprise is Hagay Pesco, the VP of Engineering at Mosaic ML. Hagay, it's great to have you on.
Hey there, thanks for having me.
Hagay is going to help us determine that decision, is going to showcase how to approach developing and leveraging large language models in the enterprise. In his previous work experience at AWS, Meta, and now at Mosaic ML, Hagay and his teams have built tools for machine learning engineers and scientists, shipped large-scale AI systems, and helped organizations deal with training state-of-the-art AI systems. A lot of insights here to be shared. And with that, I'm going to go off camera and I'm going to give this to you, Hagay. Just a bit of housekeeping before we get started. Do ask as many questions as you can. There will be a recording that will be sent to you of this session, either at the end of this week or early next week. And yeah, as a reminder, there is Q&A throughout the session, so make sure to ask your questions. And now I'll hand it over to you, Hagay.
Right. Hi, everyone. Thank you, Adele. Thank you, Reese, and the entire DataCamp team for setting up this session. So my name is Hagay. I'm the VP of Engineering at Mosaic ML. Now we're actually part of Databricks. And at both Mosaic ML and Databricks, we are hard at work on our mission to make AI accessible to any organization out there. And in this session, we're going to discuss large language models, or LLMs, is how we refer to them, and how each and every one of you in the audience can actually unlock the value these models offer and deliver value for your organization, your enterprise, the organization you're part of. And for me, actually, one of the things that is exciting, I've been watching the list of people joining the session, and it's exciting to see people from so many different countries. I really think that AI is this new technology that is going to enable a lot of good things for many people across the globe. So I'm personally really excited about the opportunity to talk to all of you across really the world on how you can use that technology. Okay, so with that said, let's jump in. So we'll start by actually understanding what LLMs can actually do for us. And as it turns out, the ability to deeply understand and generate human language opens up a lot of different capabilities. LLMs can solve math problems and even explain step by step how they got to a correct solution, which is, understanding step by step actually makes us human understand so much better. LLMs can also write paragraphs or stories and change their style of writing at your request. And there are already companies like Jasper or Writer that are already making use of that capability and empowering marketing professionals. And of course, the potential is much broader than just marketing. Now, in finance, there are models such as Bloomberg GPT that are already able to answer financial questions, analyze financial sentiments, and handle other finance tasks. And lastly, LLMs can even code and solve coding questions, such as the ones some of us may have been practicing out on LeetCode that are used in software engineering job interviews. There are tools already out there, such as Replnet Ghostwriter or GitHub Copilot. Those tools are already making developers much more productive using LLM technology. And the reality is that this is just the beginning. New applications, new use cases are popping up literally every day. One of the most exciting use cases for me is AI agents that are able to actually handle higher level goals autonomously. There is really a true, sea of opportunities for organizations that will leverage LLMs. Now, to better understand what LLMs are, we can take a short walk down a memory lane, if you will. Natural language processing, or NLP for short, marries really two distinct research fields. One is linguistics, and the other one is computer science. Now, NLP's goal is to make computers understand our species' natural language, including all quirks and nuances, as well as be able to generate natural language text. The field started somewhere in the 50s with Alan Turing when he published a seminal paper, Computing Machinery and Intelligence. And in that paper, he proposed something he called the imitation game. We typically refer to it today as the Turing test. And that's a test for intelligence, really. And the Turing test tried to test the computer's ability to show intelligent behavior through natural language understanding and generation, to the point where actually humans cannot distinguish the machine intelligence from a human intelligence. And of course, that Turing test captured the imagination of so many people. I remember myself earlier in my career as a computer science student was really excited about that test and about how can we actually build software that actually is able to pass that test. And today, by the way, there is kind of a common agreement that we have already passed the Turing test. Now, following Turing's work, the field started in the 50s with symbolic NLP, over there on the left of the slide. With symbolic NLP, experts defined rules, and the software applied these expert-defined rules. There was actually a lot of optimism at the time, and someone even wrote somewhere, someone in the field wrote that within 3 to 5 years, machine translation would be a solved problem. Now, they were right about machine translation being a solved problem. They weren't too right about the timeline, because it took about 60 years for machine translation to be solved. And it was also not solved with symbolic NLP. It was solved with today's technology, neural NLP. So again, there's a lot of optimism at the time, a bit prematurely. The field then moved to statistical NLP, starting in the 90s. And the emergence of the internet really created vast amount of digitized language data that algorithms could study. And with statistical NLP applied to the huge amounts of data out there, we actually started seeing good results in applications such as translation, spell checkers that we kind of are all used to today. So there was some success, although the real hard problems were still unsolved. And then from the late 2010s, neural network came along and really completely revolutionized the field. It was built on top of major leaps. Many of these actually came from the field of computer vision. NLP leveraged algorithms such as backpropagation, GPU optimized matrix multiplication, and all the tooling for neural network that was built. A lot of it was built for computer vision. NLP was able to leverage that, and of course process the vast amounts of data that became available of the internet. Wikipedia, all the social media, and a lot of that content. Now, at some point, Google introduced the transformer architecture, and a couple of years later, OpenAI scaled that architecture further and built GPT. And as models were scaling up, what's called emergent capabilities started appearing with these LLMs, because they were able to handle tasks they were not explicitly optimized for. At this point, the acronym Large Language Model, LLM, was coined, and many research labs started studying and open sourcing LLMs, and a growing number of companies started exploring building applications on top of these models, as they were really showing new capabilities in understanding language and generating language. So this took us to where we are today. So with LLMs being where they are now, there's a lot of excitement, but there's also a perception across the field, and that perception is something that limits the adoption of LLMs. The perception is that the ability to leverage LLMs is limited mostly to deep-pocketed organizations with an AI budget in the millions, and that LLMs are beyond reach for most organizations out there. And the perception exists for a good reason. LLMs are very large, very computationally complex. And if you take a close look at the chart here, it shows the growth in language model sizes. over the past 5 years. And you can see that the growth is almost an order of magnitude every year. And actually that trend continues. Once if you update this chart with GPT-4, for example, you can already see that we're above 1 trillion parameters. And indeed, OpenAI spent something like a reported $4 million to train GPT-3. The numbers for GPT-4 are kind of in the ballpark of $100 million. Google spent similar amounts to train their own models. And seeing this growth, hearing those dollar amounts, indeed makes all of us think that LLMs are only for the likes of OpenAI and Google. But is it really so? Well, the perception is one thing, reality is another. LLMs are definitely within reach for most organizations out there today. You just need to figure out what's the right adoption path that works best for your company, your team, your budget, and most importantly, your needs. There are a few options for leveraging LLMs, and between these options, almost any organization out there can find a way that would work for them. I'll quickly go through the option and then dive deep into each one of them. The first option is just consuming LLMs as an API. And there are today a few companies offering sophisticated models behind APIs. You know, everyone knows about OpenAI's APIs. There are other companies such as Cohere and MosaicML, the company I'm part of that is now part of Databricks, also offers such APIs. The second option is leveraging an open source model, potentially fine-tuning it for your needs, and then deploying it. Again, there is a growing number of models available from organizations such as Meta AI, Luther AI, and MosaicML as well. And these models are actually getting better and better. And we'll talk a bit more about that. And then the third and most secure, most flexible option is actually pre-training your own large language model from scratch. This typically involves leveraging a managed infrastructure from a cloud provider, such as AWS or others, and also involves higher cost, higher complexity. Although it's not to the extent of I think what's kind of the common perception in the media, and we'll get a bit more into the weeds on that. Okay, so let's start by diving into the first use case, API-gated LLMs. So the advantages of this approach is, first and foremost, it's fast and cheap to get started. I mean, all you need to do, sign up for an API key, use your favorite programming language to make API calls. It's pretty cheap to prototype since you're only paying for the API usage, typically cents or less for every 1,000 tokens of input and output. So fast and cheap. The other advantage is that you don't need any machine learning expertise or machine learning infrastructure. All you need is to know how to code an API call. You maybe need to learn a little bit about prompt engineering, but that's pretty much it. This is a code example here, simple code example showing how we'd make a call to the MosaicML LLM API. Again, it's very simple. This just shows a Python code. Provide the input prompt, and you get. And lastly, this gives you access to a model with some pretty impressive general purpose language skills. These models can handle tasks that just a couple of years ago were considered really science fiction. Example here was generated with MPT-7B, 7 billion parameter model that is also open source. And you can access such a model through a hosted endpoint or to the Hugging Face hub, or you can just load it up yourself and run prediction, run inference against the model. Now, some of the challenges here. Now, while it's easy and cheap to get started, as your usage scales up, the costs will rack up as well, and very quickly, especially if you start making extensive usage of the API. Remember, you're paying for both input tokens and output tokens, and especially for chat application where you need to provide the entire context is the prompt, entire history of the conversation is prompt. Cost does rack up. So it's very cheap to get started, but once you deploy it at scale, it becomes very expensive. And while making API calls to an external service is convenient, you're also sending your private data out into the wild and actually outside of our control. This may put your data at risk and may conflict with compliance requirements some companies have, such as SOC 2 or HIPAA for healthcare. In fact, this issue is a real deal breaker for many companies in verticals such as finance and healthcare. And there's been a lot of debate around that, especially around using OpenAI, with some companies having their data leak this way. So that's definitely a challenge and something to watch out for. Third, just like you are using these general purpose APIs very easily, your competitors can do that. They can achieve the same level of AI capabilities as you through using APIs pretty easily. And you're not really building a moat for your business by using these LLM APIs. And lastly, because you do not own the model, your ability to customize it and adapt it to your specific use case is very limited. You have the flexibility to customize it through what's called in-context learning, or ICL, where you design the prompt in a way that customizes the model's output. But that's basically it. You can't do any more advanced customization. Okay, so to recap, using API-gated LLMs, some advantages: moving very quickly, no ML expertise required, and really getting access to powerful general purpose capabilities. On the challenges side, very expensive at scale, have a risk around data privacy and compliance, and doesn't give you any moat or any ability to heavily customize the model. Okay, let's take a deeper look into leveraging open source LLMs. Yeah, so with open source LLMs, you're actually picking a model from a rapidly growing list of LLMs trained and made available by various labs and companies. This is actually a chart I pasted from Meta's recent LLaMA 2 paper. And LLaMA 2, which is Meta's open source large language model, it actually published just, I think, last week or a couple of weeks ago. So it's very new. What's exciting about this chart, I know there's a lot of text on it, but it shows helpfulness human evaluation results for LLaMA 2 chat. That's a variant of LLaMA 2, compared to other open source and closed source models such as ChatGPT from OpenAI, Palm Bison from Google, as well as the open source Falcon 40 billion and MPT from Mosaic ML. Now, I think there are two things that are really incredible in this chart, and I encourage you to check out LLaMA 2, check out the paper that Meta published. It's a very interesting paper. It goes into details about how the model was trained and evaluated. The first incredible thing is that there are a growing number of very good open source models with varying sizes. It goes from Mosaic ML's 7B MPT, which is relatively on the small size, and up to Meta's LLaMA 2 70B, so 70 billion parameters. So that's already on the large side. Now, so the variety is growing. Now, the other exciting thing is that we have an open source model, LLaMA 2 from Meta, and it's competitive. If you look at the top bar, it's competitive with one of OpenAI's best models, ChatGPT. Notice if you look at the chart, LLaMA 2 70B chat was on par or better than ChatGPT for about 67% of the time. For me, this is groundbreaking because we have an open source model that is better than one of the best closed source models out there. And that open source model is available for all of us to use. It has a commercially viable license. So that is very exciting. Now, it's important to know that this is just one evaluation. It was a human evaluation. And obviously, these human evaluations have some biases. They not necessarily are fully comprehensive, but I think it's a very exciting result. Now, the other thing I'd say is that this list here is definitely a partial list. The list of open source models is constantly growing. And suffice to say that you can all expect a new, bigger, and much better model, open source model, coming out of Mosaic ML as well in the next few months. So stay tuned for that. Yeah, so that's very exciting. Now, another key advantage of open source model is that you deploy these models on your own production environment. And so you retain full control over the data sent to the model and returned by the model. So you have the ability to have full control over data privacy. And then what's more, you have also the full flexibility to customize the model in actually many ways, one of which is fine-tuning the model on your own data or fine-tuning it for a specific downstream task. We can even take the model architecture and just pre-train the model from scratch. We'll get to pre-training from scratch in a bit, but you have full ability to customize the model. Now, on the challenges side, while open source models are getting much better and very rapidly, as we saw in the previous slide, they're still lagging frontier model. I mean, the best, one of the best models out there today is a closed source model, GPT-4, which I think many of us have had the chance to try out. It's truly a remarkable model in terms of its capabilities. And open source models, while catching up, still have a gap. My personal belief is that in the fullness of time, we may be in a world where open source models are the state of the art. And the reason I have that kind of belief is that the same thing happened in other areas in technology, such as operating systems or web servers, where open source didn't start as the leading solution, but after a few years or decade or two, actually open source is leading the way. Linux, open source operating system, is the most popular operating system today. And we saw the same on databases, web servers, and other technologies. Now, time will tell if my prediction is true or not. But what's clear is that open source models are closing the gaps rapidly. The other challenge is you need to pay attention to licensing. Since not all open source models allow for full commercial use, make sure to read the fine print, consult with counselors, and be careful not to unintentionally expose your company to a legal liability. And lastly, using an open source model does not relieve you of the need to have proper ML expertise and tooling, because you still need to understand the model, choose the right model for your needs, understand how it works, integrate it into your systems for both fine-tuning and deployment. So it does require a certain level of skills. Okay, so recapping, advantages of open source LLMs. You have a growing selection of models to choose from. You have full control over data privacy and customization. On the challenges side, the open source model may not be still the state of the art or the best out there. You need to pay attention to licensing, and you need proper ML expertise and machine learning tooling to be able to handle these models. Now let's dive into the third option, training your own LLM. Now, a key attribute of this option is that you have full and complete control over your model. It means you can customize it as you see fit, you can optimize it as you see fit. You're not at the mercy of anyone else who built the model, and then you kind of need to align with whatever decisions they made. The training data is also in your complete control, and it's something that is hard to control for open source models because they've already been trained. And controlling the training data is especially important for enterprises. Because as an example, you may want to remove training data that is biased in some ways. You want to make sure you have full rights to use the training data. And in fact, this is a pretty hot topic. As an example, OpenAI, as well as Meta, are now handling class action lawsuits against them due to copyright infringements. That's the claim that they've violated copyrights with the training data they use for training their models. So that's definitely an advantage, something you can control by training your own large language model from scratch. And just like open source models, you have full control over data privacy and an even stronger proposition for compliance requirements. since you control not just the inputs and outputs during prediction, but you also control the training data, as we discussed earlier. Now, since you're in full control of all aspects of the model, from choosing the size of the model to the optimization you apply for inference and up to the serving infrastructure, this is the most cost-effective option for serving at scale. And we discussed earlier how consuming LLM as an API is very cheap to get started, but at scale, it's becoming very, very expensive. Training your own model from scratch allows you to really control cost to a high degree. And we'll talk about a couple of examples for training your own model in a bit, and you'll see how this control takes effect. And then last, and maybe the most important thing, training your own model from scratch is enabling you to create a very deep moat for your business, since it's going to be very difficult and very expensive, very complex for your competitors to replicate your model. Okay, now going to challenges. One of the main challenges of this approach is that training from scratch does take a lot of GPU time and can be costly. GPUs are all the rage these days. They're actually very difficult to acquire even on the cloud services. If you try to get A100s from NVIDIA or H100s, which is the latest and greatest GPU, you'll find that it's actually pretty hard, and the cloud provider may require you to put a significant upfront commitment, which adds to the cost of training a model. And although as algorithms become more efficient and compute get cheaper in the fullness of time, this cost will be kind of pushed down. However, training large models is definitely not on the order of millions, as many people think. At MosaicML, we published the cost to train of our open source models, MPT-7B, so it's a 7 billion parameter model, MPT-30B, 30 billion parameter model, and you can check out our blog post. Training MPT-30B with a 30 billion parameter model is in the area of $700,000 to train from scratch, full training from scratch, and the 7 billion parameter model is much cheaper than that. So definitely not on the order of millions, although it is expensive compared to the other alternatives we discussed earlier. And of course, the other challenge is you need machine learning expertise to train such models. You need the expertise to decide on the model architecture, to customize the architecture, to go through the training process, and then deploy the model for inference. Although, as we'll see later, tooling is getting much better, and you can leverage tooling such as MosaicML platform to take care of a lot of the pain, a lot of the heavy lifting in training such a model. All right, to recap the third option, advantages of training your own LLM. You have full control over the model and training data, full control over data privacy, very cost-effective serving at scale, and helps you build a deep competitive moat for your business. Now, on the challenges side, upfront training cost is going to be expensive, and you do need machine learning expertise within your team. Okay. All right. So there's a lot to be gained training your own LLMs, as we just discussed. And what's more, when training specialized LLM for your specific use case, these models can actually be smaller. They can cost much less to train and especially to serve, and still perform just as well or even better than larger general purpose models. And I wanted to share a couple of examples to make that more concrete. Replit is the world's most popular online coding environment. If you haven't tried it, I highly encourage you to try it out. It's pretty cool. Develop code in the browser and deploy it very quickly, and do a lot of cool things like sharing your code very easily. Replit has a code assistant feature called Ghostwriter, and the model that powers Ghostwriter was actually is a model that Replit trained from scratch. It's called Replit Code V1 3B, So as you can see, it's relatively small LLM, only 2.7 billion parameters. It was trained on about 500 billion tokens. And what's interesting, and it was trained specifically for coding tasks, right? So it's not a model that is good for general language. If you try to do a chat with this model, it probably won't do that well. If you ask it to solve math problems, it's probably not going to do that well, because it was trained specifically on coding. I think it was trained on like 20 different programming languages. Now, what's interesting is that this model is actually 40% better than comparable models, including the model behind GitHub Copilot. Although it's much smaller, it's more than half the size of that model. And this model was trained in about 10 days on the MosaicML platform by Replnet, and is a great example of how a company trains their own large language model, and because they're focused on a very specific task, they can keep this model small, they can keep the training cost low, they can keep the serving cost low, as well as the latency for doing predictions, because this model powers an online experience where a developer types something and then the model completes the code. So latency was really important. The smaller the model, the lower the latency for inference and prediction. Another example is Stanford University. So the Stanford Center for Research on Foundation Models, or CRFM for short, trained the language model for biomedical tasks. And by the way, if you're not familiar with CRFM, I highly encourage you to Google it up. They are producing a lot of interesting papers, and they have a lot of thought leadership around foundational models and LLMs. And I highly recommend use that as a useful resource for you. Now, the CRFM team trained that model in about a week and introduced a new, again, 3 billion parameter model for biomedical tasks. And that model shows state-of-the-art results for biomedical tasks. Although it's so small, it actually performed better for these tasks compared to much bigger models, such as Meta's Galactica, which I think is 120 billion parameters. So, 40x larger model, and this smaller model outperforms it on these specific tasks. Again, if you try to use this model for general purpose language tasks, it will not do well. But if you evaluate it for the specific biomedical tasks, it will actually outperform much larger models. Now, what's exciting is that both these models were trained on the MosaicML platform by these two organizations. Now, at both Databricks and MosaicML, we are drinking our own champagne, if you will. Our research team is using the MosaicML platform to train, fine-tune, and serve LLMs. And we've open sourced a series of LLMs with a commercial license. So everyone, all of you, can actually use these models and build on top of them. We also open sourced our recipes for pre-training and fine-tuning these models. MPT7B and MPT30B are the baseline models that you can fine-tune for your own tasks. And we also open source fine-tuned versions, an instruction following model, a chat model, and you can find all of these on the Hugging Face Hub and all the open source code on GitHub. And you can also get immediate access to these models for inference if you'd like on the MosaicML platform. So definitely check out these models. Let us know what you think. And this is just a small part of the bigger effort around the machine learning community, with a lot of great open source models being made available. What's especially, I think, cool about some of these models here is that their long context length. If you look at one of the variants of MPT7B, MPT7B Story Writer, it actually supports a context length of over 65,000 tokens, meaning you can actually feed it whole books, and it can actually write portions of the books for you. So it's pretty cool. Try it out. Okay, now before we wrap up, I wanted to share some tips and tricks that at MosaicML we learned the hard way, training our own models and supporting our customers who are training their own models. So the first tip is, may sound obvious, but leveraging the cloud for training as well as for inference. the cloud's utility and elasticity that saves you precious time and tons of money. Cloud providers such as AWS or Oracle Cloud or GCP offers you a highly optimized GPU infrastructure for training as well as for inference, and it includes the latest and greatest NVIDIA GPUs, good networking devices. All of the configuration is done for you. Just save you a lot of time, so you can focus on actually building the model and evaluating it rather than on figuring out all the infrastructure details. Next, just make sure to use a fault-tolerant training stack, because GPUs will fail. I promise you that. Your training job, however, should not fail as a result of GPUs failing. And next, defining your evaluation metrics before training. It's very tempting to dive straight into training using as many GPUs as possible, but you should first consider, how will you know if training is going well? Make sure to choose the right metrics for use case before training. Consolidate these metrics into a single one, because you'll typically have multiple evaluation metrics. Figure out the right way for you to get a single metric. A simple average of multiple metrics will do the great job, will do the job for that. And just define it ahead of time, so during training you can know if things are going well or not. And lastly, start small and work your way up. This will allow you to move fast as well as fail fast, and it will save you a lot of time in the long run. Okay, so we're at the end of the session. I just want to say that LLMs, and really more broadly AI, is an exciting technology that's already having tremendous impact on all of us. And I hope the time we spent here together helped you just a bit in figuring out how you can leverage it yourself. Right.
All right. So it definitely helped me, Hagay. That was a really insightful presentation. A lot of questions on from the audience here on large language models and your approach to fine tuning. I have a couple of questions myself before we get started. You mentioned at the beginning of your slide deck, you kind of showed the history of NLP, how we went from symbolic NLP to neural NLP. And how neural NLP today is really ushering in this era of intelligence that we live in. A lot of discussion today in the machine learning community around, is transformers the path towards true artificial intelligence? I'd love to hear your thoughts here. Do you think we need more than transformers to reach some form of high level intelligence that we see today from tools like ChatGPT, or do you think the key is in fine tuning, scaling, building out the transformer architecture?
Mm-hmm. Yeah, it's a great question. I think transformer is a building block that was integrated into kind of neural networks. And I think what's remarkable about transformer, these blocks, is that they really enable these models to actually improve as they see more data. And traditionally, if you even look at machine learning, even before neural nets, the limit has always been that at some point, seeing more data that didn't help. Mm-hmm. And you look at kind of traditional machine learning techniques like, support vector machines, linear models, decision trees. I mean, I've been in the field for a while, and these used to be the tools for building machine learning and AI. And the problem with these tools is that as you showed more data, at some point, the quality of the model plateaued, meaning seeing more data didn't help because the mm-hmm. expressive power of these models was limited. Now, the transformer architecture, neural networks actually more broadly, but especially transformer architecture, allows the model to continue improving, or really the loss to continue going down as it sees more data. And I think that's remarkable. Mm-hmm. There may be a new block someone will come with later that may actually learn better than transformer architectures. And I think we need to wait for that. But there are already new techniques that mm-hmm. Are being made available that build on top of transformer. And just to give one example, mixture of experts. That's reportedly the architecture behind GPT-4. And as well as, there are other companies that are leveraging mixture of experts, or MOE for short. So it's not replacing transformer blocks, but it is another innovation that builds on top of that allows us to continue scaling. So we scale the model size, we scale the ability of the model to learn, but we do it in a way that we can still both train and serve the model efficiently. So MOE is the new thing, and I'm sure there'll be a new thing after that that will continue pushing the field forward.
That's really great. And you mentioned here, for example, the concept of mixture of experts, right? Maybe kind of related to this, you actually also showed the Replit training formula, which is like, really small model, but really focused on like one specific use case, right?
Yeah.
Do you see that in the foreseeable future, for example, as companies more and more train large language models, that we're going to see the proliferation of really small models, but are really focused on specific set of tasks that anyone could access to? For example, a small GPT focused only on law tasks, medical tasks, etc. I'd love to hear your thoughts about how you think the ecosystem will evolve.
Yeah. So I mean, I'm no prophet, and I think it's hard to predict. The field is moving so fast, so much innovation. Really hard to predict how things will evolve. But what I can see currently, I see emergence of two kind of main, areas.
Mm-hmm.
One is the general purpose models that are people consume often through APIs, again, such as OpenAI APIs or Mosaic ML or Cohere or Anthropic. These are very large general purpose models. They're not good specifically to any one task, but they just can handle a broad variety of tasks pretty well. And it's definitely useful for many use cases. However, as I mentioned, they have limitations. Like you don't own the model, you don't control it. It's very expensive at scale. So what we're seeing is also the emergence of these specialized models. Now, because they're specialized, like you said, for specific tasks,
Mm-hmm.
they can actually be much smaller and still do a good job. And they're also allowing companies to build their own moat with AI, serve efficiently at scale. So we're seeing the emergence of these two paradigms. One is the general purpose. The other one is the smaller specialized models. Now, the fact that they're smaller doesn't mean they're worse. They can
Mm-hmm.
actually be much better for specific tasks. I foresee many companies would start with the general purpose one because it's so easy to get started. But then as their usage of these AI use cases grows, they would be actually pushed into building the specialized model. And that's what we're seeing actually happening today in the industry.
Okay, that's really great. Very great insight. Maybe I'm gonna start taking here some audience questions while we still have time. Really good question here from Wallace. Maybe kind of also, how does ethical AI relates to large language model? Maybe walk us through, how do you apply ethical standards when it comes to factoring into the decision of buying or fine tuning or training your own model?
Yeah, so it's a great question. I think ethical AI is a topic that is still developing, and I think our understanding of it is still limited. And I think everyone should actually pay more attention to this, especially the companies who are developing models, but also the companies who are consuming models should always ask the question. Now, a key question to ask is, is my model biased? And the model is never intentionally biased, but the model, our world, the world all of us lives in, is biased. There are prejudice against race, gender, and other things, religion. It's all out there, and the reality is
Mm-hmm.
that we feed these models training data from our world, and so the model may be biased. So again, I think bias mitigation is a key thing that both the providers of LLMs should think about and should address. And there are techniques already today to address that. I won't get into it because it's a whole, we can talk about that for hours, but there are ways
Yeah.
to mitigate bias. But the other side is the companies who are consuming these models should also run their own things like bias evaluation. And there are ways to actually mitigate bias even as a consumer of the API. So bias,
Okay.
in my mind, is a key thing.
Okay, that's really cool. Another question here from Wallace. Really interesting question as well, given especially recent news on the LLaMA 2 release. Maybe what is the primary advantage to use the Mosaic ML open source model versus Meta's LLaMA 2 open source model?
Yeah, it's a great question. I think LLaMA's models, that LLaMA 2 that was just published, it looks like an amazing model. Comes in different sizes, trained on 2 trillion tokens. It seems like from the evaluation metrics that Meta shared, LLaMA 2 is setting a new bar in terms of the quality of the model. And I think it's kind of an ongoing, I don't know if I call it a race, but it's an ongoing thing where, MPT, Mosaic ML open sourced MPT. It was actually better than LLaMA 1. Meta released LLaMA 2. It's better than MPT model. It's also bigger in size. Like the biggest model there is 70 billion parameters. And you can expect Mosaic to actually ship new models that are likely to be better. So it's an ongoing thing. I would say for now, again, you need to always ask the question of, okay, what's my use case? What are my needs? One example is, context length for MPT is actually larger than the context length that LLaMA supports. And there are different reasons for that. We won't get into it, but if your use case requires very long context length, like you need to feed long documents into the context and to the prompt, probably MPT is a better solution for you. However, if your prompts are shorter and you really care about quality, maybe LLaMA 2 is a better better fit for you. So always look into the details and figure out which one works best for your use case.
Okay. Another great question here from Ram. We're very much so invested in the skills aspect of this here. What kind of team and skill sets do you need in your organization to build your own large language model?
Yeah, great question. So there are different approaches that you can take. And I would be very opinionated here. I think if you're in an enterprise, you want to leverage LLM for a use case, you want to move quickly and you want to be laser focused on the business use case. This means you want to leverage as much tooling as much things that were pre-built as possible, so you can move quickly on your goal, which is solving a business problem. So I would also recommend use a platform, a cloud platform. I'm a bit biased. I mean, I worked with my team to build the Mosaic ML platform. I think it's the best platform out there today for pre-training models from scratch. But there are also other platforms out there, in AWS, Google Cloud, and other services. But definitely, I would recommend use a platform that takes care of a lot of the undifferentiated heavy lifting, orchestration, GPU usage, the software stack, and whatnot. Now, if you do that, your team can actually be fairly small, and you need folks that understand, machine learning, specifically neural networks, NLP, model architecture, understand, the training data needs, because this is actually one of the most important things that people don't talk about too much. Is you need to curate your data set, deduplicate it, normalize it. The quality and quantity of your data set is having huge impact on the quality of the resulting model. So you want a small team of folks that understand those aspects of machine learning and NLP. And then, this team actually does not have to be too large in terms of the number of people. The team at Replnet that trained their model on Mosaic ML was a handful of people. Yep. The Stanford CRFM team, again, a handful of people, because they leveraged a stack, a software platform, so they can focus only on the model architecture, data curation, and it allowed them to move fast. So a small team of experts in NLP and neural networks.
Okay, that's really useful insight. Maybe kind of related to the closed source versus open source discussion that we've had. I know which side you are on, but essentially, when you see like organizations like OpenAI, for example, and I hear will surface this question we got from Howard: what about assurances that OpenAI has provided that their API service is walling off data, right? Like it's not going to be using that to retrain the model. How do you view the data privacy discussion here evolving over time for closed source providers?
Yeah, it's a great question. I do think that it's about trust, right? I remember a time, again, you can see my gray hair, so I've been around for a while. I remember the time where people did not trust the cloud providers, and some companies did not migrate from on-prem to the cloud because they were concerned about data privacy and similar things. And I think it took time, I don't know, like 10, 15 years later. Now companies have trust in the big cloud providers, and they know that, they trust the guarantees that these cloud providers provide. Now, it did take a lot of time for these cloud providers to earn our trust. And they had to do it by actually protecting the privacy of our data. I think we need to go through a similar phase where we all want to see that, OpenAI or other closed source AI providers are earning our trust by showing us that indeed the data we send to the service is not leaked. I think so far they have not really been meeting expectations. There's been a lot of examples, some of them, shared in the news about data leaking, and I think we'll all want to see this trust earned. But I do think that, in the fullness of time, these companies have an opportunity to earn our trust, and we'll all trust them more. So this is one angle. The second angle is sometimes, even if you trust the company, compliance does not allow you to use such a service. And I think for some companies, again, in finance, in healthcare, where there's a lot of sensitive, personally identifiable information, you just can't send your data to an external service. And I think this is likely to continue.
Okay, that's really good insight as well. Maybe related here as well on the cost of training a large language model. Good question here from Wallace as well. What is the typical spend on creation and governance on training on your own large language model? Walk us through the range here, Hagay.
So first, I'd say I'd highly recommend folks to go to mosaicml.com/blog, and over there is a bunch of blog posts that show a lot of details about how MPT-7B and MPT-30B were trained, including all the cost breakdown. So just to quote, MPT-30B, a 30 billion parameter model, the cost for customers to train such a model is in the range of $700,000. And it's constantly going down as, hardware becomes better and software algorithms improve. So that's like kind of, that's the cost for a 30 billion parameter model. By the way, that model in terms of the quality is comparable to GPT-3, 175 billion parameters. So I know there's been numbers thrown before that, a GPT-3 cost $4 million, $10 million. That was a few years ago. So today, a comparable model training it is under $1 million. If you go to the smaller sizes, like 7 billion parameter, the cost goes down by about a factor of 4. So about maybe $200,000 for MPT-7B. And if you look at a model like 3 billion parameter models, such as I gave example before, Replnet model or Stanford CRFM model. So it's a pretty good model, but on the smaller side that is specialized for specific tasks. Training these models in the tens of thousands of dollars. So that's kind of, those are the numbers. That's the ballpark.
It's a pretty good ballpark for a company like Replnet, especially. Now, another, you mentioned here on the pricing, do you think that we're going to reach a point where the prices are going to continuously go down for training like large language models? And if so, what are going to be the contributing factors towards that decrease in price?
So I think there's two trends here, and they actually are kind of, working against one another. One trend is that the hardware keeps on getting better. And you look at, NVIDIA's GPUs, the new H100, while it's, and by the way, the NVIDIA H100, that's the latest and greatest GPU for AI from NVIDIA. And what's great about it, it comes with a fantastic software stack, CUDA, that I think many people here know and appreciate how useful it is. So the H100 now allows us to train in FP8 precision, floating point 8. And still retain, in our experience at Mosaic, trying this out, it looks actually very solid. So just it basically triples the speed of training compared to the current NVIDIA A100s. So you can see how hardware plus software algorithms are pushing the cost and the time to train down. So this is one trend. And I expect with more hardware coming from NVIDIA as well as AMD and other companies, the cost will go down. Now, the other trend, though, is that the models are becoming larger and more complex, right? And And in my talk, I shown earlier, like the growth of the model sizes. I expect this to still continue. Models will still continue growing, and then this obviously pushes the cost up. So these two conflicting trends. I think we'll have to, wait and see. The models cannot grow in size forever. There's not enough compute or data in the world to train, models that are growing an order of magnitude every year. But this is where we are now.
It's like two competing forces playing pull the rope. And we'll see who ends up winning. Another final question here before we move on. A good question here from Marcus. What is the amount of synthetic data used for training for a large language model? And do you think this could become a problem for quality of large language models moving forward?
It's a great question. I think typically still today, when people are training models from scratch, they try to avoid synthetic data, and for obvious reasons, right? Like you want to, synthetic data is usually created by machines, sometimes by LLMs themselves, and you don't want to pollute, right, the training data with something like that. However, we are seeing a growing use of actually LLM generated data for things like evaluating models. I mentioned the LLaMA 2 paper earlier, by the way. LLaMA 2 used GPT-4 to evaluate in some of the evaluations of the model. And I think it's obviously very scalable to use an AI rather than human for evaluation, but it also raises the question of, okay, so can we trust this evaluation if it was done by an AI? I don't know. I think it's a good question. We're also seeing synthetic data used for fine-tuning models, and there are models out there, open source models that were fine-tuned based on data generated by other models. So I think those are interesting trends. Now, the last thing I would say is that we're going to see more and more data out there in the internet that was generated by machines. So we may not even know, when we pull data from the internet to train, we may not even know how much of that data was generated by machines. And I expect actually that through this, a lot of the new training data is going to be synthetic. We may just not know about it. And I'm not sure what effect this is going to have, not just on the models, but actually even on our society and culture.
Yeah, that's definitely another session in the making here, Hagay. Unfortunately, we have reached the end of today's discussion and presentation. Hagay, this was super insightful. I cannot express my gratitude enough for you joining us and making the time, especially for such a busy time at the moment for Mosaic ML. For those who are still attending, make sure to check out tomorrow's live training on optimizing GPT prompts for data science. We're going to be playing around with the OpenAI API. And I do want to make sure as well, again, for those who joined us, just want to say huge thank you for joining us, especially for those who joined us, from different time zones, times that they may not be super convenient for you. And once again, finally, thank you so much, Hagay, for joining us for today's session.
Thank you, Adel. Thanks for having